Hello everyone, welcome to Tech-tronics. Today I, Shivang Pathak, with my friend Pranay Parepalli from the Sardar Patel Institute of Technology, bring to you a video on function generator and arbitrary function generator. In this video, we are going to show you the block diagram of function generator and arbitrary function generator, the working principle, the applications, advantages and disadvantages, and then we are going to show you live working and how to use the function generator and arbitrary function generator. So this is a function generator. A function generator is a type of an instrument which is used to generate different types of waveforms like sinusoidal waveform, triangular waveform, and square waveform. So this is the block diagram of function generator. You can pause the video to take a screenshot of the block diagram. Next is the working principle of a function generator. The function generator has seven main components. First is the voltage control oscillator, which is also known as VCO. It is a core component in generating an output signal. Its frequency is controlled by an external voltage. Next, we have waveform shaping circuits. It modifies the VCO square wave output and shapes it into sinusoidal and triangular waveforms. We don't need this block if we want a square waveform as an output. Next, we have amplitude control. It adjusts the voltage level or peak to peak voltage of the output signal. Next, the frequency control. It sets the frequency of the output signal and adjusts the voltage applied to the VCO for frequency control. Next is the modulation and sweep features. It enables the amplitude and frequency of the modulation. It also allows for frequency sweeping of the waveform. Next is the output impedance control. It provides control over output impedance and it is important for proper signal transfer to external circuits. Then we have finally the display and user interface. It has a digital display for monitoring and also the interface is very user friendly for easy parameter control. Let's jump to the applications of a function generator. The first and the foremost application is electronic testing and debugging. It generates test signals to troubleshoot and debug electronic components and circuits. Then, frequency response testing. Ex- Assess the frequency response of devices like amplifier and filters for performing analysis. Next, the waveform synthesizes for education. It demonstrates various waveforms to illustrate fundamental principles of electronics in an educational setting. Then, communication system testing. It simulates modulation schemes to test and evaluate the performance of a communication system. Let's see the advantages of a frequency generator. It is a versatile instrument that can produce a variety of waveforms such as sinusoidal, square, and triangular. It provides precise frequency control, allowing users to generate signals at a specific frequency. It is very easy to use. The modern function generators comes with user-friendly interface and digital display, making them easy to operate. Users can quickly set parameters such as frequencies, amplitude, enhancing efficiency in the testing and developing process. Many function generators have built-in modulation and sweep features. It allows users to modulate signals or sweep through a range of frequencies, facilitating more advanced settings and scenarios and signal analysis. Let's see the disadvantages of a function generator. Function generators typically have limited output power compared to dedicated power amplifiers. Limited signal precisions. The precision of a generated signal may not be as high as of specialized equipments dedicated to generating specific waveforms. Then, while function generators cover a broad frequency range, some specialized applications may even require higher frequencies. It is very costly, and high quality function generators with advanced features can be complex and expensive. Now, let's see what is an arbitrary function generator. An arbitrary function generator is a computational tool designed to create mathematic functions across a diverse range without adhering to specific constraints. The primary purpose of such generator is to produce a variety of functions for a multitude of applications, including scientific research, algorithm testing, educational simulations, and signal processing. This is a arbitrary function generator. Also, it has two output signals. So this is a block diagram of an arbitrary function generator. You can pause to take a screenshot of this block diagram. Let's see the working principle of an arbitrary function generator. DDS, that is direct signal synthesizing operation and waveform generation. Digital storage. The DDS circuit operates by digitally storing points of a waveform in a memory. Recall process. These stored points are then recalled as needed to generate the desired waveform. Waveform variability. Points can represent any form of repetitive waveform required by the application. Frequency control to DDS. Governance. The rate at which the DDS completes one waveform cycle governs the frequency generated of the signal. Direct relationship. Faster the completion of one cycle corresponds to higher frequency outputs. Phase progression in DDS operations. The visualization. The phase progression over one cycle is often visualized as a phasor rotating around a circle. Correlation. As the phase advances around the circle, it corresponds to advancements in the waveform. Frequency and phase relationships. Faster phase progressions result in a quicker completion of a cycle, leading to higher frequency output. Let's see the applications of arbitrary function generator. Engineers use arbitrary waveforms to simulate different signal conditions, helping identify and troubleshoot issues in electronic components and circuits. It helps to generate modulated signals, pulse trains, and complex waveforms for assessing the performance of communications devices systems under various conditions. They simulate different sensor signals, communication protocols, and electrical scenarios to assess the performance of automotive electronics under diverse conditions. They generate precise and customizable waveforms for assessing the performance of RF, that is, radio frequencies, and microwave devices. Researchers of artificial intelligence and machine learning use AFGs to generate diverse datasheets for training and testing algorithms. Let's see the advantages of arbitrary function generator. AFGs can produce a wide range of waveforms beyond the standard sine, square, and triangular waveforms. Users can create custom waveforms to suit specific testing or research requirements. Flexibility in signal generation. The flexibility to generate arbitrary waveforms allow for a precise control over the shape, frequency, and amplitude of the signal. This is particularly beneficial in applications where specific signal characteristics are needed. Arbitrary function generators often have a broad frequency range, allowing users to generate signals across a wide spectrum. This is advantageous for applications require signals at different frequencies. Programmability. They often support programming interfaces, enabling users to automate signal generation and integration into automated test setups. High resolutions. AFG typically have high resolutions in terms of amplitude, frequencies, and waveforms, providing accurate control over signal parameters. Low distortion. The generated signals often exhibit low harmonic distortion, ensuring high quality and accurate waveforms. Let's see the disadvantages of an arbitrary function generator. First, operational complexity. AFGs, especially those with advanced features, may have steeper learning curves for users unfamiliar with signal processing and waveform generation techniques. Setup challenges. Configuring custom waveforms and utilizing advanced functionalities may require a good understanding of signal processing concepts. Higher initial investment. High quality AFGs with advanced capabilities can be relatively expensive compared to simpler function generators. Bandwidth constraints. Some AFGs may have limitation on the signal bandwidth, restricting the frequency range over which they can generate accurate waveforms. And last, they are not suitable for high power applications. In higher power applications, user might need generators capable of producing higher amplitudes than what certain AFGs can provide. This was the block diagram and basic knowledge about a function generator and arbitrary function generator. Coming up next, I'll show you the demonstration of function generator and arbitrary function generator in my laboratory. So this is the function generator we are going to use for our experiment today. The function generator name is APLAB 3 megahertz multi waveform signal generator. Basically, the maximum frequency this function generator can provide is 3 megahertz. The model number of this function generator is MSG3M. The following are the specifications for the function generator. So let's start our function generator. As you can see, it has started. It has a 4-digit 7-segment display. You can display up to 4 digits. Currently, it's on voltage. First, we will explain how to adjust the frequency. As you can see, the key has popped out and it's currently on the frequency mode. There are 2 probes from which we can adjust the frequency here. The one is coarse, second one is fine. The coarse one increases the frequency very rapidly. If I change a little bit, it shows 111.0 frequency. If you want a perfect frequency, you need to first adjust the coarse one. For suppose if we need a frequency of 50 Hz currently, the point is after 2 digits. It's not shown in this display currently. Suppose we want a frequency of 50 Hz. So we'll adjust the coarse frequency first. As you can see, I have taken it to 35 Hz. Now we'll increase it gradually with the fine probe. As you can see, it's increasing only the part after a decimal. We need to adjust the coarse more. As you can see, we can achieve the 50.05 Hz frequency with the help of the 2 probes. Now let's pop to a higher frequency range. The frequency range here is 300 kilohertz. As you can see, the kilohertz lighting has started in this frequency. The current frequency is 98.17 kilohertz. You can take it maximum to about 350 kilohertz. So 300 kilohertz is the range. It's nearly 300 kilohertz only. Now let's come to the second part. Also, this can provide us with 3 different waveforms. As you can see here, there are 3 different waveforms shown: the sinusoidal wave, the triangle wave or the ramp, and the square wave. We can provide 3 different types of signals with this function generator. Now let's switch to the other part. It is the setting the voltage of the input voltage. If we click this, now it has changed to voltage VPP. This is voltage peak to peak. So this probe helps us to adjust the voltage, the input voltage we are giving to the circuit. As you can see, now the current voltage is 21.2 volts, 61 volts. So this helps us to adjust the input voltage. The maximum voltage it can provide us is 20.6 volts. Now this buttons provide the range for the voltage. If I press on 20, now 0.15 volts is the minimum, and the maximum it can go up to 2.06 volts. And if I press the 41, it changes the range. These are the 2 probes from which we can connect the output. The first probe is labeled as TTL and it has written down sync. This probe basically provides with the digital signal that is a square wave. So no matter what type of wave we apply, it always gives a square wave as the output. It gives a digital wave. The second is the function. It has written 50 ohms right here because the impedance of the function generator here is 50 ohms. That means the probes we are going to use are 50 ohm probes so that they give the perfect output. So let's connect the probe. This is the DSO we are going to use. The DSO model is Tech-tronics TBS 100C series. It's digital oscilloscope. This is DSO. We're going to start our DSO right now. This gives the 50 ohms impedance. So we're going to use a probe which has 50 ohms of impedance. We're going to connect this to our DSO channel 1. Let's verify what we have given and what it's showing. So currently frequency it's showing is 356.78 kilohertz, and the frequency here is also 356.8 kilohertz, which is perfectly equal. So now let's check this for any other waveform. Let's see about triangular waveform. I have pressed the triangular waveform button right here, which is also known as ramp waveform, and as you can see on DSO the ramp waveform is shown. Let's adjust the frequency to 1 kilohertz. I'm adjusting the frequency to 1 kilohertz by changing the range button. So as you can see, I have achieved 1.004 kilohertz, and on the DSO screen also it's showing 1.0004 kilohertz. Let's auto set this to see the triangular waveform. As you can see, now the triangular waveform is visible and the frequency is also the same. Now let's see for square waveform. As you can see, I have applied in frequency of 982.6 kilohertz, and in the DSO screen it's showing 982.6, which is exactly the same. Functions, these are all things we can do with this function generator. The function generator provides us with frequencies of different voltage, different frequency range, maximum to 3 megahertz. We can change the frequency, ports are fine. We can add a DC offset. We will show the DC offset right now. So currently there is no DC offset. If we change the DC offset, it gives a click sound. See, this click sound shows that the DC offset is now bigger. And as you provide DC offset, the peak-to-peak voltage has changed, and we can see it has moved a bit up. If I do the 0 DC offset, let's adjust the position to 0. The position is currently set to 0. If I increase the DC offset, you can see it has sunk down because we have given a DC offset to this waveform. If I increase the DC offset, as I go on increasing, the waveform changes. So this is how the waveform will look with the maximum DC offset. As you can see, when I close the DC offset, this is my normal waveform. So this all things we can do with our function generator. The function generator can provide us with only 3 types of waveforms, which is square, sinusoidal, and triangular. Now we'll see our arbitrary function generator. So this is the arbitrary function generator we are going to use. The difference between the function generator and the arbitrary function generator is function generator can give us only 3 different waveforms, that is square waveform, sinusoidal waveform, and triangular waveform. And it operates on a particular frequency range only, and a particular voltage range. whereas arbitrary function generator can give us up to 1000 waveforms. There are some given waveforms, and other we can also edit equations and then show waveforms in the arbitrary function generator. We can generate waveforms like that. So this is the arbitrary function generator we are going to use. It's Tech-tronics AFG3102 dual channel arbitrary function generator. It has a maximum frequency of 100 megahertz. The function generator we were using had only 3 megahertz as the maximum frequency range. It has 100 megahertz. The second advantage of function generator is it gives us two different output channels, whereas the function generator can give us only one output channel. Other than these two output channels, there is TTL, this is the digital output channel, and this is the input channel. These are all the buttons we can use to adjust the frequencies. We can separate the running mode, which we can't do in the normal function generators. These are some general waveforms: sine, square, ramp, pulse, arbitrary. And arbitrary is basically we can set the waveform, and when we go more, we can also set frequencies from here. Since this is a bit troublesome to use and the screen is also not clear in the arbitrary function generator, we can connect the arbitrary function generator to any PC. We'll show how to connect the arbitrary function generator with PC. The arbitrary function generator in the behind has a port for USB. The wire comes with it. We are going to just simply connect this USB cable to our PC. As you can see, as soon as we connect our function generator, a pop-up is shown that new tag source is available. It means the connection has been established. Now we are going to app our software, open our software. This is Arbitrary Express software we are going to use for establishing the connection. This is Arbitrary Arb Express. We'll start our software. So we have opened our Arbitrary Express. You can see the Arb Express, the RBR status not connected. That means the arbitrary connection has not been set up yet. And we can also connect the oscilloscope here, which we are not going to connect right now. So let's go to communications, AFG file transfer and control. Now you can see the list of apparatus here. It is loading right now. As you can see, we can see AFG3102. This is our model name, AFG3102. You can see here. We'll press on AFG3102. It will load for a second. As soon as we click here, you can see the USB port address. This is the port address at which port we have connected the arbitrary. We'll click here and we'll press connect. As you can see, we have a new pop-up here. We'll do output on. We have already ticked this. This is the input channel selector, instrument control channel selector, and we'll just simply do apply. We can see the update here that instrument is connected. We'll close this window, and now as you can see, our AFG3102 status connected is shown. As you can see, this is the screen at which we can adjust the waveforms. It has 3 to 4 different modes. This is standard waveform, equation editor. Mostly standard waveform shows different types of standard waveforms, such as sine, square, triangle, pulse, noise, DC, exponential rise, exponential decay, sync, sweep, multitone or Lorentz. We can use any of these standard waveforms either, or we can go to the equation editor, write our own equation right here, and we'll compile to see a waveform. So first of all, to see the output waveform, we have to connect the arbitrary function generator to the DSO to see the output. So let's connect the output from channel 1 to DSO channel 1. We can also set up a 2-channel connection right here. We have connected the channel 2 also. So currently the waveform set here is sinusoidal waveform, sine waveform. So the DSO is showing a sine waveform of 10 megahertz frequency. If we change the, let's see, suppose we need exponential rise waveform. We'll preview here. So you can see exponential rise waveform has been shown here. We'll send it to arbitrary channel 1. It will load for a second. Do you want? Yes. It will load here. You can see file transfer status is ongoing. As soon as the file is transferred, the waveform has been transferred. Let me opposite. The waveform has been transposed, and this is the exponential rise. Since the frequency is 1 megahertz right now, so that is that you can see a bit disturbance here. If we set to some other kind of waveform like triangular waveform, let's send it to arbitrary channel 1. File transfer status ongoing. As you can see, it has transferred to arbitrary channel 1. So we can see a triangular waveform right here. This is a triangular waveform, you can see. Now let's send other waveform to channel 2. Suppose we need a sync waveform which looks like this to channel 2. So we'll click here, we'll select channel 2. Just load this in the once. Now send to arbitrary channel 2. File transfer status ongoing. As you can see, it has transferred to arbitrary channel 2. The blue color is channel 2, the yellow color is channel 1. Auto set. See, you can see the Lorentz waveform in the DSO. Basically, we can control our arbitrary function generator with the help of this software to make it easy, and we can also customize the equations from equation editor right here. We can do sine, cos, exponential, logarithmic, integer. We can do many different equations from here. We have to input our equations here. We have to compile, select the number of points, select the range, and we can send it to the DSO through the arbitrary function generator. So basically, this is the advantage of arbitrary function generator using over function generator. It can provide us with thousands of different waveforms, and we can also use it with the help of PC. And also it provides two different waveforms at the same time, and thus this is the use of arbitrary function generator and function generator. Thank you for watching this video till the end. Please like and share the video and subscribe to our channel. Thank you.